So here's the game plan. We're going to do a couple more problems where we're putting it all together. We're going to write the equations like we did yesterday, but then we're also going to graph them like we did the day before. So that we can see, what does all this mean? Why do we care? Why do we do this kind of thing? Okay? Then tomorrow, the white piece of paper that I gave you, we're going to have, that's homework. Let's do the odds today, and then we're going to start class off going over some of them and doing some of the evens. And then I have a group practice thing where we're going to work on problems like as a group, 3 brains or 2 brains better than 1 kind of thing. Does that make sense? So that's the game plan for the rest of the week. Sound like a deal? Okay, so, alrighty, so, here we go. A clothing company makes jackets and pants. So, what's my variable? What am I manufacturing? Jackets and pants, right? So the very first thing that I can think of is that, hey, that's what I'm manufacturing. So that means that when we X equal to my jackets and Y equal to my pants. Good? Okay, so let's look at what all we're talking about. Okay, so each jacket requires 1 hour of cutting and 4 hours of sewing. The pair of pants has 2 hours of cutting, 2 hours of sewing, and my total time available is 20 hours and 32 hours. Okay, so that means that for my X and Y, we're looking at cut time and sew time. Does that make sense? That's what it takes to make a pair of any item of clothing. You got to cut all the material out and then you got to sew it. Okay, I actually think cutting the material out when you're sewing something actually takes longer than sewing it together. All right, so what we know is 1 hour for cutting, 4 hours of sewing, and my pants take 2 hours of cutting and 2 hours of sewing. Good so far? All right, so the total time for the day, so that's my constraints. Okay, I can't have more than 20 hours for cutting, and I can't have more than 32. So it's a less than or equal to 20 and a less than or equal to 32. Good? Okay. All right, now, what's the next step? Write out your inequalities, absolutely. So I'm going to look at each line, and I have 1x plus 2y is less than or equal to 20. I have 4x plus 2y is less than or equal to 32. What do I always going to include? Perfect. X is greater than or equal to 0 as y, and y is greater than or equal to 0. Because basically, we're talking about manufacturing something, so we have to be in the first quadrant. All right, so I'm going to draw my quadrant, my first quadrant, and for some reason my graph didn't print, so we're going to wing it here. All right, so I'm going to do in twos. So I have 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. And then my y-axis, I'm going to have 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Try to get it as close as you can, but I'm going to give you the points since for some reason the graph didn't print when it was printing out, which is weird. But okay. All right, I need one more equation. What do I need? What other equation do I need? I like my inequalities, but then there's one other equation that I always have to do. I'm thinking about my profit, and I want to know how many. I need my profit equation, and I make 14 on the jackets and 8 on the pants. Everybody with me on that? All right, let's graph some equations. So, x plus 2y is less than 20. If I subtract my x, I'm going to get 2y is less than or equal to negative x plus 20. Let's divide by 2. So y is less than or equal to negative 1/2 x plus 10. Good. And because I had done this before, just to make sure everything was right since the graphs didn't print, I have a y-intercept of 10. And if you go down 1 and over 2, you would end up with an x-intercept at 20. And so that's going to give you your line. Everybody good with me? All right, let's do the next one. So I have 4x plus 2y less than or equal to 32. Let's subtract 4x. I'm going to get 2y is less than or equal to negative 4x plus 32. If we divide it all by 2, y is less than or equal to negative 2x plus 16. So again, 16 is my y-intercept. I went down 2 over 1. I would end up with an x-intercept at y. And they're both less than. So that means that I end up with the feasible region at here, 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 and there. Everybody good about that part? Mary, does that make more sense now? Okay. Good? Okay, what are the coordinates of my feasible region? Well, 0, 0. Since all of these have to have x is greater than 0 and y is greater than 0, do you think 0, 0 is always going to be one of the points? Yeah, because that's your origin. Okay. Then I have 0, 10, and I have 8, 0, and I have 4, 8. Good so far? Okay, now we have our function p is equal to 14x plus 8y. And we're going to use that in order to determine what we need for maximum profit. Okay? So if the P of 0, 0, what am I always going to get for that one? 0. Because anything times 0 is always going to be 0. Okay? So the P of 0, 10 is going to give me, my equation's 14x plus 8, so I'm going to have 14 times 0, whoops, plus 8 times 10, and that gives me 80. Now, if I do P of 8 and 0, I get 14 times 8 plus 0, which gives me 112. And if I do the profit for 4 and 8, I get 14 times 4 plus 8 times 8. And if I plug and chug that in the calculator, that's going to give me 120. Okay. So, bottom line, what's all this mean? What do all these numbers mean? What's my minimum? Yeah, my minimum is going to be 0 at 0, 0. My maximum is going to be what? 120 at 4A. So in context of the story, what does that mean? Yeah, so the maximum profit that they can make in a day is, what was it, $120 if 4 jackets and 8 pants are sold. Why would a business care about that?
You can make more profit than you can do.
Yeah, like what if it costs, like, we know, let's say, so without, we know what it costs labor-wise. Let's say if we're making, if it costs us $100 to pay the employees, and then we have $50 for like utilities, like your electric and gas and all that good stuff. That's $150 per day. Are we going to make any money?
They're going to lose $30.
We're going to lose $30 a day and be bankrupt real fast.
Just ask the people in that.
Or Sears, unfortunately. Okay? So this is valuable information as far as so that the companies know, hey, we got the maximum we can do within our constraints is this, so we have to keep our expenses under this amount so we make money. Okay, good? All right, make sense so far? All right, let's do another one. All right, we have a liquid portion of a diet. It needs to provide at least 300 calories. It needs to provide 36 units of vitamin D and 90 units of vitamin C. Okay? If it says at least, what does that signal to you? It at least, yeah, at least is, it's an inequality, right? If it's the inequality, what part of my equation is that going to be? That's going to be my constraints, right? 90. So we have a dietary drink X. It gives us 60 calories, 12A, and 10C. And we have drink Y. That gives us 60 calories, 6A, and 30C. And we have some costs. All right, so what variables do you want to use? How about X equals drink X? That makes sense? Y equals drink Y. Make up my little chart. And look, this time I have calories, I have vitamin A, and I have vitamin C. So how many equations am I going to end up doing? 3. Because I'm going to have calories, and then I'm going to have vitamin A, and then I'm going to have vitamin C. Then I have no extra space because I can't measure correctly. Okay. All right, ready? So, cup of drink X gives me 60 calories, 12A, and 10C. Drink Y gives me 60 calories, 6A, and 30C. Okay, now last time when we were doing the cutting and the sewing, the most we could use was like a certain hours. And so we used less than or equal to, right? This time we have at least, because it's the minimum, so we need our calories to be greater than or equal to. So that means that it has to be, the calories have to be at least or greater than or equal to 300. Vitamin A has to be at least, so greater than or equal to 36. And vitamin C has to be at least or greater than or equal to 90. Making sense so far? Awesome. All right, let's draw our graph. We just need 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 2, 3. And then we're going to need 1, 2, 3, 4, 5, and 6. All right, let's write our equations. Start with calories. So 60x plus 60y is greater than or equal to 300. So that gives me 60y is greater than or equal to 60x plus 300. And so y is greater than or equal to x plus 5. Everybody good on that part? What did I do, Chris? Okay, now I just make check and make sure I did right. All right, so my x-intercept's 5. If I had gone down 1 over 1, I would have ended up with my x. My y-intercept's 5. My x is also going to be 5. Okay, and it's greater than. So that means that's everything above. Good. All right, let's do vitamin A. So I have 12x plus 6y greater than or equal to 36. So when I solve for y, I'm going to have 6y is greater than or equal to negative 12x plus 36. So when I divide everything by 6, y is greater than or equal to negative 2x plus 6. So y intercepts at 6. And again, if I went down to an over 1, I would get to an x-intercept of 3. And so greater than or equal to everybody good? All right, last one for vitamin C. 10x plus 30y greater than or equal to 90. Subtract my 10x, I get negative 10x plus 90. Divide by 30, and I get y is greater than or equal to negative 1/3 x plus 3. And that one's going to have a y-intercept of 3 and an x-intercept of 10. And it's everything above there. Okay, now this is a funky one because this one has, it's not a bounded region, right? But if we think about what we're talking about a drink, you know, can you drink 100 cups of dietary drink in a day? Technically you could. I mean, it might be a little gross, but you could do it. So you could be way off the chart. So the thing that we got to look at then for our points is all of the different intersection points. Okay, so for instance, we have 0, 6 because all three of the lines hit on that one. And then we have this intersection point right here of 1, 4 because all of the lines are hitting on there. And then we have this point right here because all of the lines are enclosed in it, and that one's 3, 2. And then we have this point right here because all of the lines are enclosed into it, and that one is 6, 1. Okay, does that kind of make sense how that works? All right, so our function is that it costs 12 cents per cup and 15 cents. So we're going to have a cost of x and y is 12 cents for x and 15 cents for y. Okay, so this time we're looking at we're not just looking at profit, we're looking at a cost value. How much, what can I drink to get the best value and not have to pay $1 bazillion. Okay? All right, so cost of 60. That's going to give me 0 times 0.12 plus 0.15 times 6. So that gives me 90 cents. So to get where I want to be, it's going to cost me $1, roughly. And I have 1/4. So 0.12 times 1 plus 0.15 times 4. And when I plug and chug that in the calculator, that gives me a cost of 72 cents. All right, what's my cost for 3/2? Well, 12 times 3 and 15 times 2, plugging and chugging, 66 cents. I like that. That's a lot lower than any of the other ones. And then let's try 6/1, my last one. So 0.12 times 6 and 15 cents times 1 gives me 87 cents. All right, so I'm going to want 3/2. So it's going to cost me 66 cents to get 3 servings of X, and then 2 servings of Y, to get at least 300 calories, 36 units of A, and 90 units of C. Okay? Does that make sense? Usually on all your food stuff where it says minimum and it has less than or 2 min, that's what somebody at the manufacturing company has done. They've sat there and done all this work for you so that they put it on the thing. Which was nice of them, wasn't it? All right. What homework are we doing tonight? It's 3 problems. Easy peasy.